This process also ensures that application can handle all exceptional and boundary cases, providing a robust user experience. Now, this word is very, very important for us. Software testing can be divided into two steps. Step one is the verification, and then comes the validation. Internal applications, workings of the application is not required. There it is must. It is also known as a closed box testing. There it is called as a clear box testing. Good morning and welcome to the first session in Unit 5, 5th semester Software Engineering for BCA, where we are going to talk about software testing. Now, this is a very, very interesting topic. Why? Because software testing is the most important process of a software development cycle. Now, it involves not just verification, it involves also validating that software, seeing that whether it is actually working as per the needs of the consumer. Now, we might think that software testing is all about just looking into the app, whether finding that the functions are working well, whether the buttons are there in place, the web page is working. It is not just about that, but it is about a deeper understanding whether all the functions are working according to the specifications that we have discussed upon. So this would also require the satisfaction of the user understanding the design and development. As we move further, this process also ensures that application can handle all exceptional and boundary cases, providing a robust user experience. Now, this word is very, very important for us. Why? Because there are many a times where we have not defined the exceptional cases. So what if a user encounters a situation that we have never thought about? So the aim of a software testing is to keep in mind all the functionalities on board, understanding how it will go, where it has to move further, and where we need to look into it in terms of the developmental aspect. So keeping all that in mind, we are going to build this particular software testing process. Similarly, we need to understand, to develop that high quality standard of testing, one has to go through the complete network, the complete way of doing it in the style that it requires, how we need to build it, where we need to build it, how we need to take it forward. All those things have to be involved in that completely. Followed by, what is the software testing method? This is a method to assess the functionality of the software program. It checks whether the actual software matches the expected requirements and ensures that the software is bug-free. When I say the word bug-free, it should not have any kind of malicious virus or any unwanted factors inside which can disturb the functionality of the software. So we don't want that. Why? Because if you get into it, if you are into that factor actually, and it starts building up a contrast, it starts building up a negativity in terms of functionality, then we are not delivering what the customer exactly wants. Followed by which, what is the software testing? It's performing an end-to-end automation, including AI-powered codeless testing, mobile app, or the cross browser. We are looking into it. UI testing, we are doing it with test grid, so that we are going to see that the functionality is not just at the web page level, but also the internal functions, the connectivity, the database. When we are looking into the graphics, the user experience, everything is matching accordingly. We need to understand whether the software has got the capacity to scale itself to the needs of the user. So that's where we're going to use this word scalability, which is very, very important. Why? Because is the software able to upgrade itself, append itself to the next level, to the needs of the user as prescribed? Now, followed by which, software testing can be divided into two steps. Step one is the verification, and then comes the validation. Now, verification refers to the set of tasks that ensure software currently implements that specific function. Are we building the product right? Now, this is a very, very important question here. Are you doing the right thing to build the product? It is not that I know the product. It is not that I have done it many times. But are you doing the right thing that has been mentioned? The right product, the right kind of custom, the right kind of functionality that has been asked by the user. Validation. Now, this is a step where you're going to check whether different set of tasks that the software has been traceable enough to meet the customer requirements. So are we building the right product? So now what I'm going to do when I do the validation is I'm checking again and again whether it is matching the customer requirement. So that's where validation is an important step of software testing. Followed by which defects can be identified early. The importance of this, it improves the quality of the software and increased customer satisfaction. Now, we cannot develop a software which will always be defect free. Practically, that is not possible. But yes, we can understand and detect that defect even before it goes into production, even before it goes live. So the aim of software testing is to detect that particular defects, that particular malfunctions, so that the customer does not experience any kind of difficulty. So what we are trying to do here is that we will identify the bugs, we will remove it, and we will give a quality software to the customer which gives him an enhanced experience, a good experience of using that particular app. The second thing is that it improves the quality of the software. Now, the quality of the software is primarily dependent on the testing factor. Why? Because 100 times or 1,000 times when the user is going to use the app, the function should not change, the function should not get manipulated, or the app should not get disturbed by any angle. So which means to say that you are able to deliver the quality function again and again. Followed by which increased customer satisfaction, because we're going to talk about reliability, security, and high performance. Today, whenever we are talking about apps, the most important thing is that whether it is secured, whether it is reliable, whether I will be able to trust the app and do some transactions by it, or can I go ahead in terms of using the app, referring the app, can I use it for my office purpose, for my home purpose, whichever functionality can I trust on the software. So all these factors are dependent on testing. Followed by which helps with scalability. As I was speaking earlier, whenever we are talking about this word scalability, it means to say a point where suppose we are not able to work with the application. So can we upgrade? Can we start moving further? Can we add further features and improve the scalability levels? That's where software testing comes into picture, where you identify the capability of a software. And it saves the time and money. Why? Because if you are going to launch a software which is full of defects, and again the customer comes back with complaints, that's going to be a huge cost in again developing this software right from the scratch, and you need to pay a huge amount of money for this development activity. So I would always say that the testing helps us to save money and time altogether. Need for software testing. Software bugs can cause potential monetary and human loss. Now, this is where you see that if you don't do this factor, the bugs can cause a huge amount of damage to the physical life as well as to the business standpoint. Now, let's just take an example here. In the year 1985, Canada's Terac 25 radiation therapy malfunction because of a software bug led to the lethal radiation doses to patient, leaving 3 people dead and 3 more injured. Why did this happen? Because they forgot to test the bugs that are involved in that particular software, in that particular thing. The year 1994, Chinese Airlines Airbus A300 crashed due to software bug, killing 264 people. If they would have taken that moment to check whether that avionics software is working or not correctly, they could have saved the life of 264 people. But unfortunately, because of the negligence, I would say, we had to lose the life of 264 people. Now, the similar thing, a software bug cost the entire US bank crash, where 823 customers to be credited with $920 million. So that was a huge malfunction. 1999, that Again, it led to a 1.2 billion because of a military satellite launch problem. 2015, we all know about it. One of the software bug in a fighter plane F-35 resulted in malfunction, because of which it was not able to detect the targets properly. And that was again a huge loss to both life and limb. So this is where I'm trying to project the factor that a minimal testing, that if it's not being done, you cannot ignore it. You cannot say that testing is not important. Testing is very, very important. Rather, it is mandatory, as good as coding or any other step. Without testing this software, if you're going to launch it, if you're going to take yourself into an overconfidence mode and do it, this can lead to huge loss in both in terms of financial as well as the physical assets. Now, characteristics of object-oriented architecture, when these are all the things that were posed in terms of understanding why this kind of bugs and the testing is needed. Why? Because this will actually make us understand what are the objects that are not functioning as per the requirement. Because whenever you are bringing in a software, there are multiple objects that are interacting with each other. So when you are testing, each and every object needs to be verified against that case and see that whether it behaves exactly. Suppose it is not, then automatically you have to go back to the development team, raising a red flag and saying that this is not working as per our needs. So every time it is our mandatory show cause factor that you check it out, you find out where are all the challenges and do it accordingly. Followed by which, let's try to understand the different types of software testing. So we have the manual testing and automation testing. Under the manual, we have the white box, black box, and the gray box. Under the black box, you have the functional testing and non-functional. So what are under the functional testing? Unit, integration, system testing. Under the integration, incremental, non-incremental. So you have a top-down and a bottom-up approach. Now coming to the non-functional, performance, usability, compatibility. So under the performance, you'll have load, stress, scalability, and stability. So now you can see that testing has got a whole lot of activities which needs to be performed step by step to understand the better functionality of the program. Now, moving further, the software testing can be getting into the broad classification. Functional testing is where we are starting, which software testing where we validate the system against the functional requirements. It's performed to check whether the application is working as per the software function requirements or not. Now, the various types of them are integration software, smoke testing, and so many other factors. Now, what is a non-functional testing? It's a type of software that will check the application for non-functional requirements like scalability, portability, stress, and all those functions. So you will be able to see whether the software is working according to the needs and the usability levels are matching or not. Now the next one will come the maintenance. So once a software is built, you need to check under the maintenance testing whether it is keeping up to the customer's need. It involves all kind of regression testing, find out the code if it's not adversely affected, and how we are leading it from the front in terms of working with the other parts of the software. Now, similarly, we are also going to talk about this manual testing. This is the oldest form where it includes a software testing manually run by the tester. The tester takes the role of an end user and he tests to identify any unexpected behavior or bug. There are different stages for manual testing altogether, such as unit testing, integration testing, system testing, user acceptance, plans, scenarios, everything is being inbuilt to see the completeness of the testing. So that's where it ends up, and it includes exploratory testing, and you identify all the errors into the system. So this is how the manual testing works, where you are doing it manually step by step to identify whether each and everything are working accordingly. Followed by which you have the automation testing. It is also known as where the tester writes a script and uses another software to check the product. Automation is one where you can just write it and leave it for some time, rerun all the scenarios automatically, repeatedly in a faster manner so that you are able to find out how it is working. And this is definitely far better compared to that of the manual testing. Now, when we talk about the regression, the automation testing is also used at an application level, performance stress point of view. It increases the coverage and the accuracy standpoint, which makes this testing much more interesting. Followed by which we are going to talk about the black box testing, which means to say that the tester does not have access to the source code and the software interface is conducted without any concern of the internal logical structure as it is. Whatever that has happened, I'm just going to test as it is. I don't have any knowledge about the internal systems, how the software system is working, what it is. I have absolutely no knowledge. I'm just going to test as what it has been given to me. Whereas on the other hand is the white box testing, where I have the awareness of the internal source, how it is working, what is the code and how it needs to be conducted, and all the operations of the system are well known. I'm very much aware about that. So that's where the white box testing comes into picture. Followed by which we'll also come to the gray box testing, which is the tester should have the knowledge of implementation. However, they need not be expert. So they should know what it is, how the implementation is going to be, but they don't have to be an expert in that particular field. Followed by which this is the difference where I would try to talk about the black box and the white box. Under the black box, internal applications, workings of the application is not required. There it is must. It is also known as a closed box testing. There it is called as a clear box testing. End user, testers and developers, normally done by testers and developers. This can be done only on a trial error method, whereas here you fix the boundaries, you know what it is, and you will test it accordingly. Now followed by which the unit level testing, the next one where you test it at the lowest level possible, starting from one unit. Then you start integrating the levels of unit and it is tested in the form of a group. So that's what we call it as a integration testing. Followed by which the system testing, where you will take all the groups together, integrate it, put it as a system all together. Compliance will be checked against specific requirements. Acceptance testing, where you check the acceptability of the software. So you first check whether it is acceptable, the user can take it, whether this can be taken into position, the purpose of this test, compliance is with the business requirement, and then you check into the assets function. Now then comes the continuous testing, the involvement of users. Why? Because these functionalities are very much important in a real-time environment where you will see that I continuously test with the developer to find out whether there are errors. Are we matching the standards every point of time? Because sometimes what happens is that the developers might take things into confidence, into their own ideology, saying that everything is working fine. But then when a customer comes up with a complaint and says that this page is not working, this button is not working, or this functionality is not coming into picture, then you find that the testing has gone wrong somewhere. So you need to get into that continuous testing. You need to involve the user at every stage, understand the functionality and see whether the requirements are matched on a day-to-day basis. Followed by which do not skip on any of the regression testing, or do not take the programmers should avoid writing tests. Now let's not bring the developers into testing. Testers will do their role, the developers will do their role, and every time you need to go through that regression testing so that you are able to find at what levels we are able to reach the quality of the software. Now the best practice is service virtualization, which means you stimulate the system and services that are not yet developed are missing, thus enabling the teams to reduce dependency and start testing the process sooner. This can modify and reuse the configuration to test different scenarios without altering the original environment. That is very, very important for us. Next, the product quality testing ensures that the delivery of high quality product as errors are discovered and fixed early in the development cycle. Customer satisfaction aims to detect the errors of vulnerabilities. All those factors are being checked. The usability testing is also put into position so that you are able to see how the users are working as per to apply that particular application. Now with this, we also talk about the benefits, which is cost effective. The security concern in testing is also looked into it, because the more you do testing, you can find out whether the app is secured, whether it is cost effective. And on a conclusion mode, I would definitely say that software testing is not just about running through the scripts, running through the codes and finding out defects, but it is also about meeting the quality standards and ensuring that the customer gets what he wants. So when you are promising the customer that the functionality of an app would be to a certain level, to a certain extent, it has to be to that standard, and that's what testing ensures all about. With this, I come to the end of this particular session. I hope and believe that all the concepts that have been discussed here would be of a great help to you both in theory as well as in the practical walk of life. In the upcoming sessions, we would be concluding about what are all the different factors of software engineering, and I hope and believe that you have enjoyed the session thoroughly. Thank you once again for joining me today on this wonderful session.